Okay, in this video, I want to go over the formulas for a centroid of a region. But I'm not trying to get into too much physics. I'll just show you guys the formulas and I'll tell you guys what are the things you have to remember. So here we go. Let's talk about this one first. The region is under f of x going from A to B. First thing first, we need the area. But to get the area, okay, we have to do the following. This is curved, it's no good. We'll use rectangles for it. So let me just draw a rectangle right here. And the idea is that we'll be labeling things along the way and then we'll come up with the formulas. First thing first, this right here is just a small change amount in the x-axis, right? I will label that as dx. And then right here, you see this is the vertical distance, so this is the y value, all right? Well, the area of this red rectangle is just this times that, base times height. So here we go, we are making a tremendous amount of progress. First, let me write down y times dx. And you can also call this the differential area, d capital A. It's just this little area right here. And this is supposed to be really, really small. Okay, well, we have to add them up now, going from A to B using integration. So we integrate this going from A to B. That's pretty much the area. However, y is not invited in the x world, but it's okay because y is just f of x. So in other words, we know that the area is just the integral from A to B, f of x dx. That's it. So go ahead and find your area first, okay? The area of this region. Now let's talk about the x bar, namely the x coordinate of the centroid of this region. It seems that it's somewhere right here maybe, right? Because I think it's like bigger here, so it should be toward here, right? But I don't know. Again, we'll be using rectangles. Because when we have a rectangle right here, the idea is that the centroid is right exactly in the middle. Where? Seriously, literally right in the middle, right there. Halfway, isn't it? Right? Now, this is what we need. First of all, when we have x bar, we need to divide it by the area. It's seriously just like the total moment over the total mass. And when you have region, if you are assuming you have homogeneous, like the density is equally distributed and all that stuff, you just need to divide it by the area, right? So let me just put that down right away. 1 over A, right? 1 over A divided by the area, which is this part. Now, well, we are going to do the following. X coordinates, so you have to count, right? You have to keep track of distance from the y-axis horizontally to here. And that distance is precisely x. And this dot right here, it's meant to be the centroid of this red rectangle, right? Well, let's see. This distance from here to here is just x. Horizontal distance is just x. So what we need is x. And the next thing we need is we actually have to multiply by the area of this red rectangle again. So I will just multiply by y dx. It's pretty much the idea, y dx. And real quick, the idea is that you have to find the total moment about the y-axis. And this right here is pretty much the moment of this rectangle about the y-axis. So you have to look at this distance because the moment is the distance times the mass right here. But again, I'm not going to do too much physics. If you want to do that, you have to multiply by the density of whatever this plate is made of, all that stuff. But the density and the density will cancel out, so don't worry too much. Anyway, again, distance times this red rectangle's area, x times y dx, okay? But this is only one rectangle. We have to add them up again. So that's the integration part, going from A to B. That's pretty much it. And now the idea is that, again, y is not invited in the x world. It's okay, just bring that in. So I will write this down right here for you guys. Ladies and gentlemen, x bar is equal to 1 over A times the integral from A to B, x times the function, namely f of x times dx. So this is the x bar formula. Now let's talk about the y bar. Y bar is of course the y coordinate of the centroid. It seems to be like this, but again, we'll use rectangle for it, which is right here. Again, we have to find the total moment, all that stuff. The key is the distance times the area. That's the idea. We just need to find the distance from here to here. That's all. Very easy if you kind of just follow along. And usually in my class, I do demonstrate the physics part and all that stuff, use the seesaw, total moment, total mass, all that. But this is what you have to remember if you have to find the area of a region. Anyway, here's the deal. When we are looking at this rectangle, the centroid is seriously right in the middle. The distance from here to here is exactly the halfway. The whole thing is y, so halfway, of course, from here to here is just half y. That's it. So let's put this down. Y bar, again, we have to divide it by the area. So let me put down 1/8 for you guys. And we have to multiply 1/2 y right here. And times the area of the red rectangle is again y dx right here. Right? So again, distance times the area of the red rectangle. That's all. Distance from the centroid to the x-axis because you're talking about the y bar. So this is this right here. And we are going to add them up just like this. So we are going to integrate it from A to B. So that's pretty much the idea. Now, y bar is equal to 1/a integral A to B 1/2. Usually people put the 1/2 inside of the integral because we want to keep the 1/a on the outside, just like this and that. Y times y is of course y squared, but again y is not invited in the x world, so we just put that right here. Therefore we get parentheses f of x squared dx. And ladies and gentlemen, this right here is the y bar formula. Distance times the area. That's pretty much the idea that you can remember right here. Okay? Now let's talk about what if we have this region right here. Namely, under f of x but above g of x. Assuming that f and g, they don't intersect, right? So we'll just look at it like this. Well, again, we have to find the area first. I don't know how to do it. I just know how to use rectangles. So perhaps I'll draw a rectangle right here. So let me just put this down right here. And it doesn't have to be the left endpoint or right endpoint. Just draw a rectangle. Okay, that's all. Now, here's the deal. Earlier, from here to here, it was the whole y value. Right? From here to here is the whole y value. But this time, it's from here to here only. From here to here is actually just the first y value, which is y1. But you have to take away this part. So it's y1 minus y2. So this is just y1 minus y2 for the height of the rectangle. Right? So this portion is just y1 minus y2. Right? So let me just indicate this right here, y1 minus y2. And this right here, it's again dx. So I will just put it down right here, dx. So just kind of remember that's dx. Okay, area is really similar. Base times height. So we have y1 minus y2. We have to figure that out first. So put a parentheses, and then we have to have the dx. y1 is f, y2 is g, assuming f is above g, right? And of course, we have to integrate this from a to b. So we can write this down. A is the integral from a to b, f of x minus g of x. And you have to have the dx, of course. This is the area of this region, right? Now, let's talk about the x bar of that. Again, let's look at the x bar of this red rectangle. It's again right in the middle, okay? So, let's see. This right here is almost the same though. You see, x bar is equal to 1/a. This is still the same. You still have to have the integral, but let's talk about it later. Let's find the distance. X bar, we need the distance from the y-axis to here, the horizontal distance. From here to here is still equal to x. So we'll just put down x. And the reason that we don't really write it down as x bar is because the x changes, so we label this as x, okay? X And we have to multiply by the area of the rectangle, which is just this part, isn't it? So I will just multiply by y1 minus y2 times dx. Same thing, huh? And then we have to integrate this from a to b. That's the idea. So we have x bar equals 1 over a, integrating from a to b. And this is just x times f of x minus g of x. So f of x minus g of x, like this. And don't forget your dx. So here is your formula for the x bar when you are talking about in between of two curves. Now, here's the tricky part for the y bar of this right here. Earlier, it seems that we just do the f minus the g. That's okay. A lot of people will just do f of x minus g of x and then square the whole thing. Maybe that's not correct. Let me show you why. So let's talk about y bar. I know for sure we have to divide it by the area. So let me just put that down, 1 over a. If you would like, you can put down the integral, but that's later. Because we need the distance. Now, the distance is the tricky part. The area is still y1 minus y2 times dx. That's okay. The distance is the tricky part. I need to find out distance from here to here. Let's see. Okay. How can we do that though? Again, we have to find the middle of this and that. The middle of this and that is precisely the average. The average is actually 1/2 times y1 plus y2 for the average. Just a quick idea, okay? Just a quick example. Suppose this right here is 10 and this right here is 4. How would you find the middle right here? You do 10. Let me just write down 10 for you guys. You do 10. You do 10 plus 4, which is 14, and then divide it by 2, you get 7. That will be your distance from here to here. So again, we are trying to find the middle of this and that, so you have to do 1/2 times y1 1/2 times y1 plus y2 for the average. So we'll write this down. We need 1/2 times this, which is y1 plus y2. This is the distance, right, from the x-axis up to here. This is the middle of the top and also the bottom. And we still have to multiply by the area of this red rectangle. So you see, you just multiply by this part. So we get parentheses y1 minus y2 dx, right? And as always, we have to integrate this from a to b. And now, check this out. This is actually equal to the following. 1 over a, integral from a to b, and we still have 1/2. Again, the formula right here, it's not big parentheses, f of x minus g of x, and then square. It's actually, you see, this times that, you get y1 square minus y2 square, right? This times that, you get y1 square minus y2 square. In another word, we get f of x square minus g of x square. Right? So let me put that down right here for you guys. We have to multiply by, the first is f of x, and we square that, and then minus, the second is the bottom function, which is g of x, and then we square that. So again, it's y1 square minus y2 square, right? And let me just box this for you guys nicely, like that. And with that said, this right here is the formula for the x bar and also the y bar when we have, two pieces right here. So this right here are just an example, and now let me just erase this. Okay, and that's it, right? Leave a comment down below if you guys have any questions, and for my Cal2 students, hopefully you guys find this to be helpful. At least leave a comment down below, just say hi, and I'm saying hi to you guys as well. But anyway, this right here is it.